Hello, hello. So in class today, I ran out of time, so I didn't get to talk about the most interesting part about exponents. Um, we talked about we talked about just the positive and the zero, right, which was 1.5. We talked about negative, which was 1.6. Now I want to actually show you some work we can do with the exponents so that you guys can rock out 1.7. First, a negative base. There's a huge difference between negative 3 raised to the power of 2 and a negative 3 raised to the power of 2. Right, so verbally they kind of sound different, but these parentheses make a world of difference. And let me show you what this looks like expanded. So this one, all right, over here, is negative 3 times negative 3 times negative 3. Okay, so the negative stays with it if it's in the parentheses. This one here looks more like this. Negative 3 times 3 times 3. So in this one, the negative is not distributed. It's the opposite of 3 to the second. Maybe that's a good way of saying it. This one is the opposite of 3 squared, and this one is negative 3 squared. And the difference is just where are the negatives going. Now, oh wait, I'm drawing an extra 3. I was doing cubed. Sorry, so let me delete those, and let me delete that. There we go. That makes much more sense, because there's 2 of them, right? It's squared. Now you actually get a very, very different answer here. Negative 3 times negative 3 is positive 9, right? Because negative times a negative is a positive. Over here, you get 3 times 3 is 9, but then we have to bring that negative over. You get negative 9. So the whole point here is the parentheses matter a lot. When it comes to negative exponents, it's really a game of evens. Because if you have a negative base raised to an even power, your answer is always going to be positive. And the reason for that is these negatives pair up with each other, right? So we have negative times a negative gives us a positive, negative and a negative gives us a positive, negative and a negative gives us a positive. So when it's even, you'll always get a positive answer. When it's odd, like 7, you'll always get a negative answer, because we know all of this here gives you a positive, but then you throw out this final negative and you get a negative, because a positive times a negative is a negative. So all this is positive, and then these become positive too, right? So positive, positive, positive is just positive. Positive times a negative is negative. So that's how these work. So I encourage you, notice the exponent. Is it positive? Is it even? Or is it odd? Because that's going to tell you if your final answer is positive or negative. Now, let's see here. Earlier, if you recall in class, I told you that 3 to the negative 4 is the same thing as 1 over 3 to the positive 4, right? Make it a fraction and make it positive. That's basically what I said. If you see this negative, make a fraction, 1 over, and then put the positive. What I didn't mention as class is what do you do if you already have a fraction and you do 3 to the negative 4? Well, you just flip it again. So you do, that gets flipped over here, this gets flipped over there. So you get 3 to the positive 4 over 1, which is just 3 to the 4th. So negatives, you just flip them. If it's on the top, flip it to the bottom. If it's on the bottom, flip it to the top, right? So on this one, we have negatives. Pretend this is a fraction. We have 4 to the negative 3 divided by 4 to the negative 5. These just get flipped. So that one goes here, and this one goes here. And we get 4 to the positive 5 over 4 to the positive 3. So you just flip them. That's pretty simple. If you see a negative, you flip it. Fractions as a base are not as scary as you think they are, right? If you see something like 2, that's a 3. Whoops. Let's try that again. If you have 2 to the 3, or 2/3 to the second, or squared, you just multiply it by itself, right? So you have 2 over 3 times 2 over 3. And of course, you know, when multiplying fractions, you just go across the top. So let's go ahead and make our fraction symbol, because we're going to need that. 2 times 2 is a big O 4. 3 times 3 is a 9. So 2/3 squared is 4/9, which doesn't reduce, right? So that is the final answer. And that's not that bad. So whenever you see a fraction, I just encourage you to write it out this way. If it was, let me make a new page. If it was 2/3 to the third, that's really no more intimidating. It's just 2 over 3 times 2 over 3 times 2 over 3. 2 times 2 is 4. 4 times 2 is 8. 3 times 3 is 9. 9 times 3 is 27. And that's it. That's your final answer. So 2/3 cubed is 8/27, which I know that sounds intimidating, but the math behind it's not that bad, right? Because we're just multiplying across the top, multiplying across the bottom. So there are 3 things we can actually do with an exponent. You can multiply them, you can divide them, and you can raise them to another power. So when multiplying, we call this the product of powers property, which basically just says x to the a times x to the b is x to the a plus b. And I know that's a bit of a mouthful, but really this portion here is what you should be looking at, a plus b. So if this was a 1 and that was a 4, then we would have x to the 5th, because 1 plus 4 is 5. And that's it. The only thing is the bases must be the same, and this is an absolute huge point. So let's look at this. 3 cubed times 3 to the 4th. Well, this is our a, that's our b. 3 plus 4 is 7. 3 to the 7, because 3 plus 4 is 7. Super easy, right? You all can add. What I want you to do is actually pause this video and see if you can figure out the answer. X to the 10 times x to the negative 8. I know I'm throwing in a negative, which makes it scary, but I believe in you. So pause the video, give this a try. Okay, hopefully you paused that. So 10 is our A, so we have 10 plus our B, which is negative 8. 10 plus negative 8 is the same thing as 10 minus 8, which is 2. So it should be x to the 2, right? C. So hopefully you picked C, because 10 plus negative 8 is 2, x squared, x to the power of 2. Boom. Let's try that again. This time things are a little bit different. We have x to the negative 10 times y to the 8. See what you can do there. Go ahead and pause this video and see what you can do. Okay, hopefully you paused that. The answer is actually E. Uh-oh. Some of you may have said negative 10 plus 8 is negative 2. So some people may have said D. but you forgot something super important. The base must be the same, right? X and Y are not the same base. So 2 to the third times 4 to the sixth cannot be reduced, right? So it's just done. And the same with X and Y. So if we said that's X and that's Y, we're done. It's already simplified because the base must be the same. And the same is true with dividing, only now instead of adding, you subtract. So a to the m divided by a to the n is a to the m minus n. And I know when I talk about all these variables, it intimidates people. So let's look at an actual problem here. First, notice the bases are the same, xx, which means we're good to go. Now it's just 5 and 4. So it's x to the 5 minus 4, or x to the 1, which we can just simplify down to x, right? X to the 1 is just x. So that's how that works. It's subtraction. So now you try this one and see if you can get the answer. So pause the video. Okay, did you notice that the bases are different? Uh-oh, did I trick you? Maybe I did. If so, it's okay. So x and y are different bases. The base must be the same. So we're done, right? Because they're different, we're done. If, however, I make them the same base, now we can actually do stuff. So do me a favor, pause the video, see what you come up with. Okay, so hopefully you said the answer is x to the 7 minus negative 22, right? Because it's, going back here, m minus n. So we have m, oh, that's the wrong one, m minus n, right? And n's negative, so we have to incorporate that. A negative or minus a negative is the same thing as plus a positive. So it should be x to the 7 plus 22 is 29. A was the correct answer there. A, right? Because minus a negative is plus a positive. And if you're confused about that, if I said like 3 minus negative 1, we just go bloop bloop, 4. 3 minus 1, though, is just 2. But again, 3 minus negative 1 is 4, because we can bloop bloop it. So keep that in mind as you're working these. The last thing we're going to talk about is power to a power, which is just multiplication. It's the exact same thing we've been doing, except we're not adding, we're not subtracting, we're multiplying, right? So if you see a power being raised to a power, we multiply. And that, here's the reason. This is in D2L. I thought it did a great job explaining. This is 7 squared multiplied by itself 5 times. So we have 1, 2, 3, 4, and 5. But each one of these can be broken down like that, because 7 squared is just 7 times 7. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the 10. 5 times 2 is 10. So this is the long way. Multiplying these is the short way. So let's look at this. I bet you can do it. Pause the video, see what you come up with. All right, if you said x to the 8, you're correct because 4 times 2 is 8. This one, it's negative 8 because negative 4 times 2 is negative 8. And really, that's all there is to it. I bet you can do 1.07 now, which is this one. Good luck.